Well, hello everyone, and welcome to this special live event brought to you by the B1M in partnership with Holobuilder. I'm Fred Mills, I'm the founder and MD of the B1M, and I'm going to be your host for today. And I'm joined by a truly awesome panel of experts to talk about one of the greatest feats of engineering we've ever pulled off on this planet. I've called this a live event, but it really is much more exciting than that. We've got really unprecedented access to an incredible project team who've pulled off, as I said, a really remarkable feat of engineering. Just to give you a bit of background and context to today's agenda, the session is going to run for about 60 minutes. I'm going to initially set a bit of context around the project and what it entails, just to give a bit of background for people. We're then going to hear from Holobuilder and understand how their tool was used on this project. We're then going to come to our expert panel with some prepared questions which they're going to answer around how the cantilever lift was undertaken. And we're then going to answer your questions. We want to get through as many of those as we can. So get your questions coming in now using the Q&A feature on Zoom, and we will try and get as many of those answered during the session. If for any reason we can't get through every question, as is normally the case, we'll answer as many as we can via email afterwards if you've consented to provide your email address. So without further ado, as I said, I'm joined by a truly awesome panel of experts today. We're going to meet them in a little bit more detail now. Raj, first of all, from ITHRA Dubai, can you tell us a bit more about who you are and your role on this project?
My name is Raj. I'm the Chief Development Officer of ITHRA Dubai, the developer behind this project.
Fantastic. Barry from ALEC is Managing Director. Can you tell us a bit about your role on this project?
Hi, I am the Managing Director of ALEC Construction. I'm responsible for all construction activities in the Middle East and have had particular technical involvement and participation in this project from the start.
Excellent. Drew, you're joining us from Holobuilder?
That's correct. I'm Drew Wandell. I'm on the new business development side of Holobuilder, and we helped ALEC get up and running, start using the system and creating a 360 view of the project.
Awesome, great to have you with us. Bridget, you're Head of Design at ALEC.
Hi, good evening. I'm Bridget Kirkman. I'm the Design Manager for ALEC on the One's a Build project.
Fantastic, great to have you with us. And last but by no means least, Dean McGrail, WSP Middle East.
Thank you, Fred. Dean McGrail, Managing Director for Property and Buildings for WSP in the Middle East. So we were appointed by Nick and Seke, who the lead consultant for the project, as the architect of record and multidisciplinary engineering consultant.
Awesome. It's fantastic to have so many different perspectives from this project team here with us. As I said, it really is unprecedented access. I need to make sure that I don't just get very excited and ask all my own questions the whole way through. I could literally talk about this all day. So just to give a bit more background, for those of you who maybe aren't aware, there is a video on this already on a certain YouTube channel called the B1M, which happens to be quite good. We're very proud to say this video is now the most watched video on this project worldwide, and it's just gone over 1 million views on YouTube. And if that wasn't exciting enough, it's actually our 60th video on the B1M to cross 1 million views on the platform. So that's awesome. I think it's testament to how incredible this project is. But also, I think for me personally, I set out to really change the perception of construction. I wanted to get it out to a much wider audience. I wanted to kind of put it in a format that was consumable and engaging to a mass audience. So to see videos go over 1 million views is phenomenal, and it never gets old, even on the 60th time, which is awesome. So if you haven't seen that video yet, A, where have you been? What have you been doing? Please go and have a look at it. And B, don't worry, because we have got a bit of a synopsis now to go over some of the key points to give you a bit of background on the One's a Build project. So this is One's a Build. It's a development in Dubai that was designed by Nick and Seke and developed and led by ITHRA Dubai. It consists of 2 skyscrapers, as you can see, over a live roadway, one of the major roadways into the city, linked by a cantilever called the Link, which, as it happens, as you probably guessed from the title, is the world's longest cantilevered building. This impressive structure is designed to create a new gateway into Dubai. It's very close to the financial district. It has a direct link to the World Trade Center. As you can see, it's a gateway, it's a structure into this remarkable world city. This picture is my favorite picture in the whole presentation, I think, because every single part of it, the more you study it, every single part of it just says Dubai, but it also says the power and the impact of construction. So as you can see, there's two skyscrapers. The slightly taller one you see kind of closer to us in the photo is Tower A. That's going to rise to 67 stories. Tower B, the slightly shorter tower, more in the background there, rises to 57 stories, and they're linked by that cantilever, which is the world's longest cantilever over that live roadway. But you'll also notice around the feet of the buildings, there's podiums, there's a 3-story podium, there is basement construction, there's a road to keep open during. In the background of that photo, there are many of Dubai's greatest achievements, including the Burj Khalifa, which remains the world's tallest building. And not least the temperature and the sun and the weather, which we'll come to in just a moment when we talk about some of the extremities of working on this site. So this was the site in January this year. Remarkable development, and I'm not afraid to say my favorite picture of the whole project. Truly remarkable. Bit of a progress update. So these pictures are from March 2021 there. You can see the buildings progressing with the cladding coming up the tower. And then in June 2021, in fact, I believe that picture was taken maybe just a few days ago. You can see the buildings are fully topped out, the cladding progressing much higher up them, and some of the cantilever fit out beginning a bit more in earnest, including the installation of cladding upside down on the underside of the cantilever. Again, something that's unique to this project, which we'll talk about in just a moment. To give a bit of context around that cantilever, I'm not going to step on the toes of the expert team because they're going to give us a bit more detail in just a moment. But it's very long. It's almost as high as Tower B, or would be as high as Tower B if it were placed vertically. I should stress this picture on screen at the moment is an illustration. It's not going to be built like this. We've just taken the cantilever and turned it vertically for illustration purposes. Inside the cantilever, well, on the cantilever, on top of the cantilever, there is a very impressive infinity pool. The weight of the infinity pool is quite a key part of this development and the planning of the construction phase, which again we'll come on to in just a moment. But you can see an extensive pool on top of the cantilever itself, and then inside some truly world-class interiors, the bar fit out, and indeed the wider fit out of the amenities inside. You can see here, I think this just shows that the world-class fit out of this building, the nature of what's going to be inside it, but also I think the scale. If you look at some of the chairs, some of the bar installations there, you can see the scale of this space that sits effectively in free air 100 meters above the ground, which is truly remarkable. Carrying on with scale, this is a key part of the construction phase. You can see the cantilever was assembled at ground level first before being lifted up into place. I think if you look at the street lamp in this picture, but you also look at the roadway in this picture, you begin to get a sense of the scale of this piece of steel effectively that was lifted into place over the roadway between the two buildings. This is a key clip from our video, and this really showcases the feat of engineering that's taken place. So as I said, the cantilever was constructed at ground level. It was lifted very slightly off the ground, about 10 centimeters off the ground initially, to check its impact on the pulleys and the skyscrapers that it was being connected to. And then when the team were ready, they lifted the cantilever into place via these pulleys. You see a remarkable feat. Huge structure being lifted up. And it was then welded into place to the two structures, before the final piece was then lifted up and placed, in itself a huge piece of steel. So that's the feat of engineering. We're going to talk about that in just a moment. But before then, I'd like to introduce Drew from Holobuilder, who's going to talk a bit about how the Holobuilder tool was used on this project. We're then going to come and hear from the expert team about how on earth they went about planning that construction maneuver on this project. So, Drew, here's your first video. You ready to go?
You bet.
Go for it.
Thank you, Fred, and the whole B1M team, and really the whole project involved in One Zabil. This is just a great iconic project to be a part of. You know, as you can see with Holobuilder, we're a simple, lightweight solution to be able to capture 360 photos, pin them to a floor plan, and really create a data set that is kind of plug and play. So now once you can easily create a digital twin of your project, it starts to create just a much smoother transition and way to collaborate across not only the globe, but this is also pre-pandemic when Alec and part of the team reached out to us. So it's been a vital effort to be able to understand what's going on site, be able to track progress, compare it against models and understand the design work versus what do the existing conditions look like, and really just create a historical context of what the entire project looks like. And now we can create workflows off of that project. So, simply put, we're trying to create a data set that people can leverage in a number of different places. And we know the AEC industry is hungry to collect more data. So, seeing a project like this, the scale it operates at, it's just crucial to have a common centralized platform that can connect both the field and the office and be able to allow this kind of high degree of accuracy and insight on the project. So, we do love to get kind of a better sense of each individual company's workflows, the data sets required, because it really is creating a workflow that sits on top of an existing business. So, we'd love to kind of set up a one-to-one conversation, learn more about the company, and figure out how we can start to put this to work. I think it's crucial that companies get into practice of being proactive about creating this data, rather than say, hey, we have an issue, we need to go back in time and not be able to have it. So I'll pass it back to Fred. Just want to provide a little bit of context, a high-level overview of Holobuilder. And once again, I really appreciate the opportunity.
Fantastic. Thanks, Drew. As you say, this is a tool that was popular before, but has really come into its own during the pandemic. The ability to have effectively eyes and ears on the ground without being there in person is a huge thing. There's a second video from Holobuilder now, which is narrated. So we're going to play that now. It's about a minute or so long, and then we'll move into our poll and back to our discussion.
That allows us to use this information in progress meetings and in progress reports. So we're having multiple uses out of this data, and it's really improving our processes. We're capturing about 8,000 images a month. Photographs are taken twice a week. So the data that we have is up to date and it's covering the whole project. That allows us to use this information in progress meetings and in progress reports. So we're having multiple uses out of this data, and it's really improving our processes. We've also been using it to show the images from site to the people who can't attend site. So we've been using it a lot during remote working and social distancing. So it's given access to the guys within ALEC who can log in and view our sites.
And then also for the guys placed on the job, I mean, what they do is they'll have meetings in the offices and they talk about various parts of the project. And it's a very powerful tool in terms of being able to pull those images up and discuss those parts of the job meaningfully, because you can see what's actually going on and it's not somebody's recollection. So yeah, it brings a lot of meaning to the meetings because you can look at things in a lot of detail and deal with it.
I think one of the images or one of the functions that really helps is the split screen. And you can easily see the difference in changes in the project from one time to another. This also helps with progress meetings where we can see if works has happened or not happened. And it generally just improves the coordination meetings on site.
Fantastic. Some good footage there of Holobuilder in use actually on the Onesabuild product as well, which is great. Now the Holobuilder team are giving out free demonstrations of their software, which is pretty cool. If you'd like a free demonstration, Zoom poll has just gone live, so you can vote on that. Sorry, it hasn't just gone live, it's about to go live now. If you can vote on that during the webinar, that'd be fantastic. So anyone that says yes to that poll, you'll be contacted by Holobuilder, and they will arrange a free demonstration with you. Sadly, not on the site in Dubai, depending where you are, but a free demonstration no less, which is pretty cool. Now back to our presentation and back to the expert panel that we have involved. I really want to find out more about this project now with the panelists. Rod, coming to you first, where did the idea come from? Who came up with the idea for this cantilever? How did it come about, and what does it contain?
We had a challenge with the site itself being unique as it is, both from a configuration point of view and its location, and the fact that it actually was bifurcated by, as you mentioned earlier, a highway. It begged for a brief that actually reflected a microcosm of Dubai. So we came up with the brief to develop a mixed-use development that included hospitality, residential, and office and retail, all in one site that reflected what Dubai stands for right now. And sure enough, when we put this to a design competition, Niken picked up the design to link to actually produce all of those components within the development. And basically that link is the thread that joins all of those components together.
Fantastic. So what kind of things are actually inside the cantilever?
First and foremost, the link is actually targeted to be accessible to all. It has a multitude of functions. As you mentioned earlier, it's actually basically internally we refer to it as a third tower. It's a third tower, but lying horizontally. It has a multitude of functions. Most of them are public, from retail to hospitality to eateries, and a couple of experiences that I think will actually bode well and reflect what Dubai stands for nowadays.
Excellent. I mean, Barry, coming to you next. Obviously, we've just heard from Radia. There was the concept. It's been conceived. How did you then go about making that happen? What kind of methodology did you put into place? What was the construction approach to pulling off a feat of engineering like this?
I mean, it's a challenge, and I mean, this project was hard bid, so we had to compete in order to win it. And we went through various iterations where we had to try and figure out which was going to be the most feasible way to actually construct it. And I mean, in doing that, we had to consider the logistics constraints. As Rod mentioned, the site is bifurcated by a 6-lane highway. The remit is that the highway was never to be shut for an unreasonable period of time, so we couldn't just shut it down. And then also you had to look at the actual constraints on the site. And what we were given as the contractor is we were given a final condition design. So it became our obligation to actually do all the temporary works to support our construction methodology. So we had to come up with a construction methodology. We then had to back that up with technical data, information, and calculations. We had to make sure that that temporary methodology had no detrimental impact on the permanent structure and condition of the building in its final state. And so we came up with the system that you guys have now seen and which is now unraveled. And basically, very simply, because of logistics constraints on the site, we decided to build a sliding platform on Tower A. So we divided the link into 8 segments, which were all roughly about 1,000 tons. We tried to make and manufacture as much as we could off-site. So obviously, there was the road logistics. The factory where we fabricated the steel was in Alhambra, which is about 50 kilometers from the site. So most of the logistics was done in the evenings. We brought in as pieces as big as we could. And I think on the project, we achieved about 80% of all the welding in a factory environment, which is quite a big achievement when you consider that just about every single element here was actually fabricated and made out of plates. And the grade of steel that was used was also a challenge. It was specially manufactured steel for this project, high grade, high performance steel, which needed technically very competent people. So the scheme that we came up with very simply was to systematically assemble the units. And because of the challenge we had with the logistics on plot B, we decided to slide them across the highway. In sliding them across the highway, we were never going to shut the highway because the elements that we were pushing across the highway were stable by themselves. And we created a nose piece, which was 24 meters long, to make sure that at no point in time would there be a tipping. So the nose piece allowed us to cantilever across the road. Once we'd completed assembling the sections, which filled the areas between the two towers, we then assembled a gantry system 4 levels above the connection point. And that ended up being one of the constraints why we actually couldn't assemble the whole link as one and lift it as one piece, because the deformation.
Stay close. Just
the deformation in the actual permanent structure was too great. And that's why we ended up just lifting the piece that sat between the two towers and ended up doing a second lift. So the gantries were then installed. So it was 6 gantries that were installed, 3 on each tower. Each one of those gantries had 2 lifting points, and each of those lifting points had 2 500-ton hydraulic jacks. And depending on the load that was being lifted at the different points, the strands within each of those jacks was between either 27 and 51. We ended up with 180 strands, each of about 114 meters long, to lift the first lift. And the first lift was approximately 8,700 tons. Now, before you can actually do the lift, the most crucial part of the project is that initial lift, because what you're doing is you're transferring the load from the podium level into the towers. And the gantry system that we designed basically used a series of levers to make sure that the loads were being transferred vertically into the tower. But having said that, there was still a deformation that we were expecting. So the buildings were built with a camber. Now, because of the eccentric loading, the camber is slightly eccentric as well, because as you can imagine, the tower, the link wants to twist by virtue of the shape and how it's connected. So we had to make sure that in our temporary works calculations, we took into account how that load was going to be transferred into the building. So before we actually did the lift, we did a series of checks to every single one of the members. We verified every condition. So if there were any visible cracks, they were monitored, etc. And then what we did in order to make sure that the lift was safe, we lifted it 100 millimeters. So the first lift was the most crucial lift, because if you can lift it 100 and it's safe, you can lift it 100 meters. So that first lift was absolutely crucial. So, and amazingly, the theoretical deformation versus the actual deformation, we were within 10%. So we were within 1 millimeter of the theoretical and the actual deformation, which, I mean, it's way and beyond anything we expected. So we left the building in that condition for 24 hours. We did the full verification and validation. We used 2 different monitoring systems. There's an active system and there's a passive system. The passive system had 1,000 different points, and we used things from tilt meters to strain gauges and laser theodolites, and we set up targets at various different points on the various structures. And every 10 to 15 minutes, there was a survey done of every single one of those points that we then plotted, and we could see exactly how the building was behaving. Once we were satisfied that there was going to be no issues, we then proceeded with the lift. The lift happened at a rate of about 10 meters per hour. We then, every 30 or 40 meters, we then had to recalibrate, just make sure everything was still behaving that way it was supposed to be behaving. And then we concluded the lift. The last half a meter was absolutely crucial in terms of alignment. And so between ourselves and the engineers, we had to make sure that the alignment was absolutely spot on, because if we go past, there's no way of going back, because the jacks are designed to be one directional, and they've got locking mechanisms in case there's a failure. And so in case of a failure, they will lock themselves. So there's no ways of going backwards. You can only go up. So, I mean, we've got it into its final position. The the next crucial part was to actually lock the structure. And because this is the link bridge is a fixed connection to both towers. And so what we did is we locked in Tower B first. Once Tower B was locked in, we then identified the ideal period to then lock in Tower A. Now, as you can appreciate, the thermal movement on this building is quite significant because it's a steel structure connected to two concrete structures. And we needed at least 20% of the welding to be done at the connection points on Tower A to overcome the thermal stress that would exist. So we needed to identify a period of time where we could actually get about 72 hours of welding in. So we managed to get that done. It took us 50 days to lock in both towers and to get 100% of the welds done. Once we had done that and we'd done full NDT testing of every single weld, we then proceeded with the stage 2 lift. The stage 2 lift, similar principles in terms of cantilevers. It was a 120-meter lift. It was the last section. The interesting thing with that lift is that cantilever, the pylon, we actually designed it to be offset from plumb so that when it took the load, it came back to plumb so that the forces acted 100% perpendicularly and behaved exactly how we wanted it to behave. So we then lifted that last section and it took us about 3 weeks to lock that into position as well. But I mean, a fantastic achievement from everyone involved, from the consultants, the specialists we had there. The guys did an absolutely amazing job. And, you know, at the end of the day, how do you define a success? You define a success is that we managed to achieve what we set out to achieve as an objective, and we had absolutely no issues whatsoever.
It's just remarkable. I think, you know, people watching will probably understand it's not just a feat of engineering. It is one of our world's greatest feats of engineering, in my opinion. I think what you know, just listening to what you're describing, you know, lifting this skyscraper-sized piece of steel, effectively that's been constructed 100 meters above the ground, constructing 2 skyscrapers that are, you know, 60 to 70 stories high each anyway, on a camber, and then bringing them back together. Some of the things you spoke about there, some of the nuances, some of the things you have to think about to make all that happen is just remarkable. I'm even more impressed now than I was before.
I mean, a simple thing like the rails. The reason we used the rails because we could jack the rails. As we were building the different segments, we would set the rail with the required camber, so that when we were building it in situ, we built it with the required camber for that section of work, so that when we lifted it, the camber was correct. And I mean, it's interesting that when we lifted it, the lifting condition versus its final connection condition has got 2 completely different deformation patterns. Because one we're lifting, the temporary condition, whereas the other one is connected on the side, so it wants to fall over.
Incredible. I want to bring in Bridget here because she's head of design, which is no small feat of a job role on a project like this. I mean, what were some of the challenges in the design phase that you were thinking about from your perspective?
Okay, thanks, Fred. I think Barry touched on a couple of them already. The things that we actually had to do to counteract the designed deformation or the expected deformation of the various components. So it was pre-cambering the towers. Each one was pre-cambered slightly differently, and each one from a slightly different level. In order to achieve the pre-cambering, we were casting each slab approximately 5 millimeters offset from the slab below, so that you actually got your buildings actually splaying slightly away from each other. Tower A at the end of the pre-camber was about 139 millimeters, and Tower B was about 122 millimeters. So that was at the top of the buildings, and that was the expected deformation when they came back together when we lifted the link. I think you've seen the link. It's completely eccentric to both of the towers. It doesn't rest on any specific element of either tower. It's connected only by welded nodes. So there's 72 welded nodes that are connected to the face of each tower. And those connections are done welding onto the embedded steel plates that are already cast in. So one of the mechanisms we also used to counteract the deformation was a composite concrete and steel structure. And that was done using composite columns, massive structural steel elements encased within the concrete. Those are the elements Barry was talking about, were the very high grade, high performance steel. It was 460 grade, and it was only available from limited factories around the world. The lead time was anywhere from 5 to 8 months for some of these sections, which meant we had to get the design firmed up ASAP so that we could get the steel to device so that it could actually be fabricated as it needed to be. Those elements were then cast into either a concrete column, or they were cast into the concrete walls, the shear walls on the various cores. And the complex rebar coordination that went along with those, and the shear studs that were on all of those different elements, created untold complications for us rebar-wise. There was an awful lot of 3D modeling and trying to make sure that it could all fit in to the shape of the columns that were actually designed. Then some of the other things that we actually, well, one of the other challenges that we actually faced was things like trying to fit a rigid facade around a building that's actually flexing over the lifespan of the construction and slightly beyond. So we all know how buildings actually settle over time. So a facade is a fairly rigid element, although we do have connection nodes, and that gives us a little bit of flexibility. Because we were cambering the building and we couldn't wait to start the installation of the facade until the link bridge had actually been lifted into position, we actually started the installation of the facade on the lower levels true to what it would actually be. But as we started cambering the building outwards, we had to actually offset the facade panels on every floor by the same 5 millimeters we were offsetting the concrete. So very precise installation tolerances that were in place. And as we lifted the link bridge, and as Barry said, the expected deflections did happen, and we managed to pull back into plumb, the facade panels have realigned themselves so that we now have the verticals lining up on all the floors. So it has worked as per expectation and as per model, which was comforting to know. Then the other thing we actually did was we actually pre-cambered the link bridge quite substantially, because not only did the link bridge have to cope with its own self-weight and the cantilever side of it, it also had to cope with all the loading we were going to put into it from the swimming pool, the water in the swimming pool, the fit out in the various levels, the precast panels we've used to create the floors within the link bridge space. All of that's added a massive amount of load. So at the end of the cantilever, we actually cantilevered the entire, cambered the entire link bridge by 320 millimeters. Thus far, it's come down about 200 millimeters. So, and it's settled into a slight camber, and that will be taken up as we continuously load the link bridge over the next couple of months or period. We will actually sink down to hopefully a flat surface. I think we've got about a 6 millimeter tolerance, which is what we're aiming for. So it's fairly precise. We calculated and recalculated and rechecked everything. So far everything's working according to plan. And then the other things that have actually created some design challenge, some installation challenge, are things like the acrylic pool on top of the link bridge. So the bottom of the pool is actually acrylic panels. They're about 80 millimeters thick. Most of them are solvent welded together. So they're brought in sections. Obviously, we've got restrictions on road width and what we can actually bring to site as a panel size. And instead of joining them with a sealant, they're actually solvent welding them together so that they form massive homogeneous panels that move in a single plane. Those panels, we've got about 3 or 4 expansion joints within the pool structure itself between panels. And those are actually filled with the sealant. So they've been designed very carefully by the specialists. And those accommodate both the thermal movement and the structural movement, but they still retain the water tightness that we actually need.
Incredible.
So those are just a few of the challenges that we encountered on the way.
You've put me off ever building a cantilevered building now. I mean,
Lots of things to think about.
Indeed. I mean, Dean, the Middle East, it feels like, is home to the world's most incredible feats of construction. So as MD of property and buildings for WSP in the Middle East, I'm sure you've had your fair share of amazing feats. I know you've been involved in some of those extraordinary projects over there. How does this compare? What were some of the biggest challenges from your perspective?
I mean, Barry and Bridget have touched on a number of them. The lift of the link, without a doubt, was probably the single most challenging aspect of the design. I mean, we started on the project in 2015 with Nick and Seke, and to see the design that we put into place then sort of come to fruition now, and you know, Bridget and Barry talking eloquently about the sort of the deflections and the tolerances that we were talking about back then come into fruition when it's actually constructed and now in place has been quite remarkable. I mean, before One Zabeel and before the lift that we did a heavy lift on the Address JBR, which is a hotel project down on Jumeirah Beach. That was about 650 ton at the time. That was about 190 meters and took us up to about level 62, and that accommodates a spa and now the world's highest infinity pool. And the deformation and the deflection on that was in these two planes. And then a similar sort of approach when we lifted the central hub for the Ain Dubai, which is the world's largest observation wheel. So again, can't sort of go into the exact weight of that, but it was more than 4 A380s that we lifted into place for the central hub. So a lot of the experience that we had in terms of those heavy lifts we brought to One Zabeel. And you know, I think Barry and Bridget have talked about the deflections and the picture that you showed with the 3 towers in effect, and the vertical camber that we had. And when that lift first started and the towers come to the vertical, you know, the three towers themselves at the start are designed as completely independent structures. And then when they come into the final position, they're obviously acting as a single element and a single structure. So the forces that go through all 3 at that point are very, very different from the point when you design, you lift, and then it all ends up in situ. Where we are now, we're still monitoring, we're still designing, and Bridget touched on the infinity pool, but where that infinity pool is located and the way the cantilever now acts, we're still monitoring, because those deflections are still happening on the cantilever, all within tolerances and all as expected. But as we begin to load the cantilever with the facade elements, with the pool, with the landscaping, we're just making sure that design and the actual cantilever itself is remaining level. We've all been to infinity pools, and the idea that there's a nice trickle of water over the infinity edge. Obviously, the last thing we need is a torrent onto the highway below. Probably one thing that we've not touched about, which I will just cover very briefly, is the 7-story basement. I mean, the 7-story basement in itself is a engineering marvel. I think, you know, it's a very few projects we work on have got basements that deep. Not only is it a deep basement, but as Barry and Rad and Bridget touched on, the highway actually bisects the 2 buildings, and the cantilever traverses across. So the foundations of the basement had to be coordinated with all of the structure associated with the highway, and we had to make sure that there was no settlement of movement of that highway bridge. So, you know, that's just a few of the engineering challenges. There was another 25 engineering disciplines that WSP had working on this project, each with their own sort of unique, bespoke challenges. But yeah, very, very interesting, unique project.
Yeah, it's incredible. Listening to you guys talk about some of the things you have to think about is incredible. I think it's worth saying, if you live in Dubai and you need something heavy lifted, WSP and Dean is the guy to call with experience now across a few different things. I mean, just one last question from me before we go on to the kind of the audience questions. I've worked on site, I've worked in pre-construction in my time. I know you've designed this thing to death. There's factors of safety, you've modeled it, you've planned it, you've tested it elsewhere, but it comes down to that one day where you're like, okay, we're gonna lift this thing now 100 meters in the air. What is that like? What's kind of going through your mind? Is it adrenaline? Is it excitement? Is it fear? I mean, what was that day like?
That to me?
Oh, to anyone, yeah.
I mean, from my perspective, it was, you know, I think we were confident. I mean, the whole team on here had done so much analysis, so much work, 15 different structural models, hand calculations, 3D modeling, computational analysis, peer reviews from Chicago, New York. I know Barry, you know, separate independent checking engineers, DM. For me, it was relief, if I'm being honest. Actually, finally lifting the link, what we've all been working so hard to achieve. And it was a great day, and I know there was a lot of smiling faces, and we're still going through that now.
Barry, as MD of the contractor, what was that day like for you?
Massive relief, but you also, you know, we're engineers, so we either believe in what we do or we don't. And like Dean said, we went through so many, and because it was so special, we were extra cautious, and there was checks and balances everywhere. And then we also had a protocol of how we were actually going to load the building. And if anything was going to go wrong, it wouldn't have been catastrophic. And, you know, so you had a couple of fail-safes there. But once the building took the load and it came back to where it was supposed to be, massive relief and, you know, a sense of achievement. So.
I mean, we're going to go to the audience questions now. I'm going to ask Rod in just a moment about, you know, how you felt that day. But just to go to some of the audience questions, first one that's come in. This is a great question, but I'd really like to get the answer to. How did you ensure worker safety was kept to the highest levels during the actual operation itself? Probably ask Barry. If that's okay.
So because it was a high-risk operation, we limited the number of people that were actually active on the site to the experts and the professionals. So we had a proper tag in, tag out system. So the control was in place, so that we knew exactly who was on site and what they were doing. If there was no reason for anyone to be on site, they were not allowed on site. We also made sure that we kept the area around clear and safe. So we had a proper lock-in, lock-out procedure to the site, and only authorized people were allowed on it. And during the critical lift periods, we cleared the site. So there was no people working on the site other than the people that are supposed to be there.
Another great question we've had come in, which is about the weather. You know, how much did the weather play a factor in this, in terms of wind or heat or even sandstorms? Was that a factor in terms of what day the actual lift happened?
Yes. So we, with WSP, we monitored the weather. We were in touch with the airport, giving us constant feedback, because we needed to make sure there was no, because I mean, in this part of the world, there's lots of gusts. So we had to make sure that we were doing it and there was no undue risk. So although we designed the temporary condition to take a certain amount of lateral load, if there was a gust, we could have had an issue, because the structure could have gone into an oscillation. So we had to make sure that the weather was right. So, I mean, we monitored from a period of time, looked at historical data, checked with the Met office at the airport. They confirmed that the next 72 hours, there was going to be no issues. And then it was one of the checks to make sure we got the green light to proceed.
Other questions coming probably for Bridget. This is quite a technical engineering one, but why opt for welding rather than bolted steel connections to connect the cantilever to the concrete buildings?
It's probably actually more a question for Nick and Sakai.
Okay.
It was actually part of the original specification. It was how they conceived the design. And we did have discussions about whether bolted connections would actually be a good alternative. There were pros and cons for both. But at the end of the day, all the checks and balances were done based on the welded construction. And that's what we actually landed up going with. So I'm not sure why they chose originally. Their initial design was that, but they believed these were stronger and they were more able to cope with the differing loads.
A few questions coming in about kind of seismic design. Was this building designed for seismic resistance, and how did you go about that with such a unique structure? Again, that's for anyone who feels they're able to answer. Go, Barry.
Dubai is a category 2A. We designed to the 2A code. The building is designed as a single structure. So it's the two towers and the link, and it's seen as a single structure, and it's designed to behave and perform as a single structure.
Another question we've had come in, is the basement connected beneath the road, or is it two separate basement structures under the skyscrapers?
It is actually connected with, below the road with two tunnels. They're service tunnels. They're connected at basement 2 level, but it's, and you can traverse them with vehicles. So it is connectable. It's not one continuous basement, however, right below the road. So it's just, it is connected at 2 points.
It bisects the foundations for the highway which runs through
the bridge, correct.
Building through the bridge. So
Yes.
That was another interesting, unique challenge associated with the project.
Yeah, the more questions you guys answer, the more complex this project seems to get. The more I appreciate it. I mean, Rod, just coming back to yourself. I know you were talking to us earlier. What was your feeling that day when you saw the cantilever finally in place? What was that like for you?
Well, it's basically a dream come true. I mean, when we bought into this design and we knew what impact this would have on the landscape of Dubai, and you know what Dubai is all about. Dubai has indeed established itself as an avant-garde attitude that there's nothing impossible in this part of the world. So for us to be able to actually see that materialize was an achievement in its own right. Actually, I'll touch on something that Dean mentioned earlier, the fact that when we did go 7 basements below the 7 basement structure, that in itself was a challenge to actually maintain that roadway in between those 2 plots and between those 2 deep holes. That was testimony to actually both the consultants and the contractors to be able to meander through this challenge and deliver without basically a hitch. So when that happened, that gave us confidence that going forward and lifting the link was just a walk in the park.
I can see their faces. They're all signing up to build more cantilever. Yeah. Barry and Drew, I kind of want to ask you about the Holobuilder tool and how that was used as well, because obviously you were using that before the pandemic, but then March 2020, we all got dealt the same hand. We couldn't leave our homes, and we're trying to sort of keep, things going. How did Holobuilder play a part in supporting this extraordinary feat of engineering?
Well, I think Holobuilder is something that, the construction industry is looking for more and more tools and an easier way of dealing with lots of data. So instead of having thousands and thousands of people running around taking photographs and then trying to coordinate and consolidate it, with Holobuilder, you've got an opportunity to walk into spaces on a regular beat and record the actual status of the works. And it's so effective that you can use it in meetings where you can have a look at the rates of progress from 1 week to the next, looking at specific items. So the accuracy of the data and the way the data is now nicely stored and consolidated. So once you've got a discipline on the project on how you want to navigate the project and record data, you've got a very effective tool that allows you to do that very efficiently, and you use the guys on site to do it. You don't need to go and get anyone else to come in and participate. And then when you're sitting with subcontractors and even with the clients and consultants, you're looking at things in real time. And particularly with COVID, when people are a little bit nervous, because Dubai fortunately managed to keep construction going throughout the pandemic, we were still able to engage with people, giving them a real-time update of what was actually happening on the projects. So they could still go into the spaces, have a look around, identify issues that needed to be resolved, and they didn't have to physically come to the sites and have unnecessary exposure. And a lot of that now has just remained in place. So it's a positive from the pandemic.
I don't think I can make the point better than Barry there using it on the specific project, but it's amazing to see the change taking place within construction technology, because we're always in a format of trying to get people more in practice of, you need to create this data because you don't know what the problems are going to be 6, 12 months from now. So having that data on hand, it's just going to give you that kind of time travel aspect to go back and know what happened when. And to Barry's point, what's amazing is seeing it as a sort of new technology. Well, we're doing some documentation, 360 seems cool. To see the rate of photography jump up. So less people coming on site, more photos being captured, more data being created, and people really needing a centralized source to be able to communicate specifically. I mean, think of the complexity that each person on this panel and the planning and methodology of every single millimeter and when it's going to happen. So if we talk about something, we need to be able to be very specific in the room, structural. It's all going to come into play to make sure that communication is smooth and seamless.
Definitely. I mean, just wrapping up before we go, I'd really like to hear from each of you. What are you proudest of on this project? I mean, it is. I don't think I'm laying it on too thick. Because I've seen a lot of, on the B1M, there's quite a few different impressive construction projects, but this is seriously an amazing feat of engineering. What are you each most proudest of with this project? Rod, coming to you first.
Well, I think what we set out to achieve in developing this particular unique development is embody the spirit of Dubai. And we believe that what we've done collectively as a team is deliver that message. So while, many developers would be content with developing, run-of-the-mill type developments or what have you, we took it upon ourselves to have this challenge be met and hopefully even exceed, cementing Dubai's position in the world as a place to look at for, an avant-garde solution to whatever challenges that are thrown at us.
So I think we can all agree this project definitely achieves that. It's phenomenal. Barry, coming to you next. What are you proudest of?
I think I'm proud of the collective effort. I mean, we have our differences and we have our battles, but the collective effort of everyone's will and perseverance to eventually have this landmark and to be a part of it is special. It doesn't happen to many people, and to be part of that, I think, is a privilege for everyone, and I'm proud to be part of that. And I think the collective effort is something we should all be proud of, creating landmarks that will be there beyond us.
Very well.
I look out my window in my office every single day and I look at this monument and I am very proud. So far, the link bridge has topped the proud moments, but I'm looking forward to the next step, which is the fit out and the culmination of the next design effort, which is to make the spaces what they actually need to be at the end, the spaces that people will actually use. These are the things that are closest to my heart, you can tell. So I'm really looking forward to that. I'm looking forward to the finished product so that it can actually be shared with everybody else. So it's been a fantastic, iconic project to work on and a great privilege.
Dean, how about you?
Yeah, build on Barry, Bridget, Rod. It's a monument. It's another iconic building on the Dubai skyline. And in many ways, it's going to be the first iconic building that everyone's going to see as they come into Dubai. My children get sick of me pointing to my buildings and my buildings. That's one that Daddy did. So it does make you proud. And everyone that's worked on this job, Barry touched on it eloquently before. Without the dedication and commitment of everyone, and not only the people on this call, Nick and Seke, project manager, the authorities, Dubai Municipality, Dubai Civil Defence, RTA, it wouldn't come to fruition. And, you get 1 weak link on any project, it can be a huge problem. You get a weak link on something like One Zabil, it can be catastrophic. So, that team spirit, that collaboration, is just something that I'm extremely proud of. And I'm proud to be on this call with everyone that we're working with and talking about this project.
I mean, Drew, your software was a key part of this project team. What are you proudest of on One Zabil?
I mean, it's pretty similar. It's really to be a part of something larger than just our small piece of technology. We like to think of ourselves as kind of the oil that's going to run in between all the major machinery of the engine. But it's really a humbling experience to be, on a panel with such level of expertise, and we're really just kind of sitting in the backdrop, hopefully providing a useful tool that's going to be beneficial not only for the project and the progress and being able to see it into the future, but seeing what took place over the last year and a half really changed the world. And it's amazing to be just kind of a part of that change and seeing what's taking space within all of construction technology. So, honored.
Absolutely. Well, I mean, for me, it's been absolute, I'm not just saying this, it's been an absolute privilege to sit and talk with this incredible panel today. If you're watching and you've not been put off the idea of building a cantilever, then if you are thinking of building a cantilever, these are the experts to call and get involved with. But I think also, for anyone that's watching, and this is kind of the key vision and idea behind the B1M, for anyone that's watching who is perhaps a bit younger and is working out what they want to do with their life, or is working in a different job role and is a bit bored of their career, construction for me is the best job in the world, because you can come in, you can work on projects like this, you can pull off feats of engineering like this, and as the team was saying, you can drive by and say, I built that awe-inspiring thing, I made that happen, I played a part in that. There's no better feeling in the world. So yeah, if you're bored of your job, or you're young and you're working out what you want to do with your life, come into construction, because you can literally work on things like this. Huge thanks to the whole team on the panel today. If you've asked a question but we haven't had a chance to answer it yet, we were going to endeavour to answer them via email. Thank you to everyone that's filled in the poll. We've had a record response rate on the Holobuilder poll, which is fantastic. I should have said at the start of the call, we've actually got Ithra Dubai and Alec and WSP all joining us from Dubai. I'm chairing this from London, and Drew's joining us from Seattle. So we've managed to get 3 continents all carefully planned into the right time of day for us all to be awake. But yeah, huge thanks to the whole panel for being here. Huge hats off to you for pulling off what I genuinely believe is one of the world's greatest feats of engineering. And a big thank you to everyone that's tuned in and taken part today. We'll see you soon. Thanks.